Hi there, we're back again. Gordon West, WB6NOA with Radio School. Hey, my buddy is listening to his little FM weather radio, and let's play around with his brain just a little bit with the capture effect. This is where the strongest signal received is only the demodulated signal. Now, I'm doing this not transmitting on the Weather Channel. I would never do that, but rather just a piece of test equipment that is so strong it overcomes the local weather service. See what happens. Here it blanks it out.
3 northwest, 6 pressure. Goo 58, humidity 72 west.
He's trying to figure out what in the world is going wrong with his receiver. No, it was capture effect. The strongest signal is the only one demodulated on FM. What is the term for the blocking of one FM phone signal by another stronger FM phone signal? That is called capture effect. Now let's go back to the receiver that I'm working on here and take a listen to that noise floor. What is meant by the noise floor, the term noise floor of a receiver? That's the weakest signal that can be detected above the receiver's internal noise. Now for VHF and UHF weak signal work on single sideband and CW and PSK31, you want to operate a receiver with an extremely low noise floor. Normally we use the GASFET transistor, which is found in these quality receivers. Now when you're down there at the ham store checking out that new radio that you're going to award yourself for passing the extra class exam, you'll see that there's a lot of specifications, and one is the blocking dynamic range for a receiver. Now the blocking dynamic range is the difference in decibels between the noise floor and an incoming signal that will cause 1 dB of gain compression in the receiver. Now if you look over the high frequency amateur radio spec sheets, you'll find that most receivers have a published blocking dynamic range of between 117 and 119. And on your examination, 119 dB, and that is going to be not a minus 119, but we always refer blocking levels as a positive number. That'll be 119, no minus, 119 dB is the correct answer. Now, here's how we solve for the correct answer. The question reads, what is the blocking dynamic range for a receiver that has a 8 dB noise figure, IF bandwidth of 500 Hertz when the blocking level, which is 1 dB compression point, is 20 dBm. The formula on page 88 of the textbook, Pn is equal to Kt times B. That is the formula for Boltzmann's constant. We work out first to minus 147 dBm in 1 Hertz bandwidth. Now, from the 147, and that is a minus 147, we have a plus 27 dB, which is 10 log 500 Hertz. That's our bandwidth. So we're adding plus 27 to the minus 147 dBm worked out in the math. Then we also add our noise figure, which is given as 8 dB noise figure. This works out to be a minus 139 dBm. Remember, we started with minus 147, and then we whittle away 27 dB and 8 dB, which are positive values. Now we're at 139 dBm minus. Now, minus 139 dBm added to minus 20 dBm, which is the 1 dB compression, will lead us to minus 119 dBm. That's 139 minus 20. So 139, 129, 119. Now the 119, which has a minus sign in front of it, is always expressed as a positive number in dB. So the answer comes out 119 dB. Now, the incorrect answers are minus 119. Nope, that's not correct. It's always a positive value. Incorrect answers are also 146 and minus 146, thinking that you might stop at the noise floor without going down to the blocking dynamic range. So again, your answer, 119 dB. Everything is worked out on page 88 of your textbook. Now, don't panic. I know you're going, uh-oh, this is going to be too much math. Nope, I'm going to help you through each and every one of these problems, and I'm going to give you reminders on our final portion of this audio course just to remember the correct answer. All right, E4C09, what is meant by the dynamic range of a communications receiver? Well, that's the ratio between the minimum discernible signal and the largest tolerable signal without causing audio distortion products. What type of problems are caused by poor dynamic range in a communications receiver? Well, they lead to cross-modulation of the desired signal and desensitization from strong adjacent frequency signals. If you measured the minimum discernible signal, the MDS, of a receiver, what would you be measuring? Well, you'd be measuring the minimum discernible signal. On your exam, they just say the letters MDS. So say it with me, MDS, minimum discernible signal. That's the weakest signal that the receiver can detect. How does intermodulation interference between two repeater transmitters usually occur? Well, it occurs when they are in close proximity and the signals mix in one or both of the final amplifiers. And how can we reduce the problems up at the repeater site of intermodulation interference between two repeaters in close proximity or maybe sharing the same antenna tower? They always choose us as the extra class ham to go up there, and we'll install a terminated circulator or a ferrite isolator in the feed line to the transmitter and duplexer. And here is what intermodulation interference sometimes sounds like.
You know, Ted, he don't tell you.
You hear about 3 different conversations going on.
Then you hear about that. I don't think he hasn't been down too often with his.
Well, that's a classic problem of intermodulation interference. And with several different radios picking up the same problem of 3 or 4 stations at one time, this tells you the problem is occurring not in the receiver of your radio, but since you have 3 different types of radios, rather the problem is occurring in the transmitter up at the repeater site. Now, if you had a receiver tuned to 146.70 megahertz and you're receiving an intermodulation product signal just on your unit and no one else's, that means it's probably a problem in your own unit, and you get this when a nearby transmitter's on 146.52, what are the 2 most likely frequencies for the other interfering signal? Now remember, you're listening to 146.70, someone transmits at 146.52, and there are actually 4 possible calculations to find the intermodulation interference frequencies for this problem. Now remember, this test question may or may not appear on the test. Look in my book on page 90 for the formula. F of the intermodulation distortion equals 2 times frequency 1 minus frequency 2. So your calculations at first are 2 times 146.52 minus 146.70, and that works out to be 146.34 megahertz. Now, if we rearrange and try the other way around, the other frequency is 146.70 plus 146.52 divided by 2, and that should come out 146.61 megahertz. So look on page 90 of my textbook and follow how I take you through the problems, and then you'll be able to solve for the correct answer. So to remember this, the receiver's tuned to 146.70, the transmitter nearby 146.52, that's simplex. The interfering signals will appear on 146.34 and 146.61. So just remember 146.34 megahertz and 146.61 megahertz, and look in the book for my question E4C14 and how we solve the explanation by working it all the way out. Now, if the signals of 2 transmitters mix together in one or both of their final amplifiers up at the repeater, and unwanted signals at the sum and different frequencies of the original signals or generator, this is called intermodulation interference. cross modulation is modulation from an unwanted signal that is heard in addition to the desired signal. Now, what can cause intermodulation in an electronic circuit in that brand new repeater? Possibly nonlinear circuits or devices in that repeater. What are two factors to determine the sensitivity of a receiver? Maybe that repeater's receiver. Well, the two factors to determine sensitivity of a receiver would be bandwidth and, did you get it? That's right, noise figure. What is the limiting condition for sensitivity in a communications receiver? Well, what would limit its potential for reception is, that's right, the noise floor of the receiver. Selectivity, not sensitivity, but selectivity can be achieved in the front-end circuitry of a communications receiver by using a preselector. And when you change bands on your worldwide, that brand new radio you awarded yourself because you passed extra, you will hear little relays go click. Those are the preselectors to give you added selectivity. Now, what degree of selectivity is desirable in the IF circuitry of an amateur radio that is to receive RTTY, radio teleprinter? There's RTTY. I'd use about a 300 hertz IF for the reception of RTTY. And what degree of selectivity is desirable in the IF circuitry of a single sideband phone receiver? Well, to pick up this...
15. Hello, CQ, CQ 15. W9. SK9.
Here we are. I'd use about a 2.4 kilohertz filter for single sideband.
CQ 15.
Now, what is the undesirable effect of using too wide a filter in the IF section of a receiver? Well, you could pick up undesirable amounts of other audio and undesirable amounts of noise to reach the audio stage. How should the filter bandwidth of a receiver IF section compare with the bandwidth of the received signal? Well, we need an IF, that's like a filter, slightly greater than the received signal.
Calling CQ 15.
He's still calling CQ.
CQ 15.
What degree of selectivity is desirable if the IF section is for an FM phone receiver? Now, FM is plus or minus 5 kilohertz, so we need an IF of about 15 kilohertz to accommodate it.
The loss of using two of them there wouldn't be worth it.
The next question, E4C26, asks about, in a receiver, if the third-order intermodulation products have a power of minus 70 dBm, when using two test tones at minus 30 dBm, what is the third-order intercept point? Now, there's the key part. What is the third-order intercept point? Now, for the third-order intercept point, we add the difference between minus 30 dBm and minus 70. Now, the difference between minus 30 and minus 70 dBm is about a plus 40. And then we take half the difference because we're looking at the third order intercept point, and half the difference will be plus 20 dB, and add it to the test tones, and the two test tones are at minus 30 dB. So that is plus 20 added to minus 30 gives us minus 10 dBm. Remember, for third order intermodulation products, always half the difference before you start your addition. Now, the last question asks, in a receiver, if the second order intermodulation products, now second order, have a power of minus 70 dBm when using two test tones at minus 30 dBm, what is the second order intercept point? Now, for second order intermodulation, it is simply the difference, not half, which we did for the third, but simply the difference between minus 30 dBm and minus 70 dBm, and the difference is plus 40. Now add that plus 40 to the minus 30 dBm, and you end up with a plus 10 dBm. So remember, for second order, it's simply the difference, not half the difference we would use in third-order intermodulation calculations. Now, if you check over questions E4C26 and E4C27 in my textbook, you'll see that I work it out for you right on paper. Now, hang on. I know your brain is about ready to swell out of this third area, the C section. Remember, we're at question E4C27. How many questions can come out of the 27 in this group? Only one. So if your math is a little rusty, don't worry about it. Maybe you'll get an easy one out of these 27 that says, what degree of selectivity is desirable in the IF section of an FM phone receiver? And you remember that is at a real wide 15 kilohertz. Okay, take a well-deserved break, and then let's jump back into section E4D01, all about noise suppression, vehicular system noise, electronic motor noise, and plain old static. E4D01, what is one of the most significant problems associated with the reception of HF transceivers, especially in a vehicle? Here it is. Boy, do you hear that noise come up when we turn the engine on? Yeah, classic spark plug noise. Well, that is one of the most significant problems associated with going mobile is ignition noise. And the proper procedure for suppressing electrical noise in a mobile transceiver is turn off the ignition. Oh, no, that's not in the question pool here. Let's see. Oh, here it is. Follow the vehicle manufacturer's recommended procedures. Is that a joke? They have none. Well, if you press real hard, sometimes you can get a factory bulletin on how to cure some of the noises associated with vehicles. And that spark plug noise was number one. Spark plug noise can be quite a problem. Hear that noise? Now, where should ferrite beads be installed to suppress ignition noise in a mobile transceiver? Well, we sometimes may use these in the primary and secondary ignition leads. But this problem right here, this is spark plug noise. Here, I've turned the engine off, then I'll turn the engine back on. Yeah, that's nasty, nasty noise. Well, my buddy came over and we did some noise suppression on the vehicle, and I think we've got it pretty well cleared up. But still, when I'm on the air, everybody says that I don't come in clear. I wonder why. Let's go ahead and start up the vehicle and see what it sounds like over the airwaves. Oh, yikes. Alternator whine. Oh, that's a tough one to identify, but it's an easy one to cure. Now, you can eliminate alternator whine by wiring your new high-frequency transceiver directly to the battery. Connecting the radio's power lead to the battery by the shortest possible path will eliminate or minimize alternator whine. Now, how can conducted and radiated noise caused by an automobile alternator be suppressed? By connecting the radio's power lead directly to the battery and by installing coaxial capacitors in the alternator leads. But do it carefully because that's a very sensitive circuit and you don't want to miswire the alternator. How can noise from an electric motor be suppressed? Sometimes the air conditioner motor will create a problem. Even the fan in our communications van will sometimes give us a lot of noise. Well, we can install brute force AC line filter in series with the motor leads if it is an AC motor. And what is a major cause of this noise? Take a listen, see if you can identify it. We're tuned into the 160 meter band. Oh, there's a couple good ones there. Oh, yeah. Oh, great ones. You're hearing lightning associated with thunderstorms. So a major cause of atmospheric noise, especially down on 40, 75, 80 meters, and 160, would be thunderstorms. How can it be determined if line noise interference is being generated within your own home? Well, hopefully you have one of those small little portable HF transceivers like the little Yaesu FT817, because you need to run the radio equipment on battery power and then turn off all of the AC power lines at the main circuit breaker in your house and see if your little battery-operated radio now has a clear reception. What type of signal is picked up by electrical wiring near a radio transmitter? That's called a common mode signal at the frequency of the radio transmitter. Keywords, common mode signal. Which of the following types of equipment would be least useful in locating power line noise? Oh, you know power line noise. Oh, what a noise. Well, what would be good in tracking down the noise is an AM receiver with a directional antenna, or a little handheld RF sniffer, or an ultrasonic transducer amplifier and parabolic reflector when you go right out there to where the big power lines are located. But something that would not be useful in locating this noise would be an FM receiver, because FM tends to minimize the pickup of AM noise spikes. Now we're on to E4, E01. What circuit construction techniques use leadless components mounted between circuit board pads? Oh, that's an easy one. That's called SMT, or surface mounting. Here's another question sort of out of place. What is the main drawback of a wire loop antenna for direction finding? Well, the main drawback is that it is bidirectional. In other words, it picks up both one way as well as the other way, broadside to the loop. What pattern is desirable for a direction finding antenna? Well, what you would like for direction finding, especially if you're looking for hidden transmitters or maybe noise, is one with a good front to back ratio and front to side ratio, like a Yagi antenna. And for direction finding, we use the principle of triangulation, and that is a beam antenna heading from several receiving stations is computed and used to plot the signal source on a map. Why is an RF attenuator desirable if you're doing some triangulation, looking for a hidden transmitter? Well, that prevents receiver overload from extremely strong signals. When your receiver goes into overload, you turn the antenna and you don't see any change. The RF attenuator would allow us to see small changes as we point the antenna one way or another way. What's a sense antenna? That's a vertical antenna added to a loop antenna for direction finding to produce a cardioid reception pattern, like a heart. And a loop antenna, several turns of wire wound in the square of a large open coil. And how can the output voltage of a loop antenna be increased? By increasing either the number of wire turns in the loop or the area of the loop structure. Why is an antenna with a cardioid pattern desirable for direction finding? Well, it has a nice deep null in the cardioid pattern, and that null can help us pinpoint the direction of the desired station. And what type of terrain can cause errors in fox hunting and direction finding? That would be varied terrain. What is the amateur station activity known as fox hunting? Well, that's an attempt to locate a hidden transmitter by using receivers and direction finding techniques. And by the way, fox hunting is now an international sport. All right, how is that brain doing after all of this material? We're now more than 1/3 of the way through your extra class license test preparation. We just covered E4 amateur radio practices, of which there are 5 test questions. One may be on test equipment, one on frequency measurement or frequency counters. Another question you might have on signal to noise ratio. You might have another question on noise suppression, and finally component mountings, or what we just covered a little bit about, fox hunting. All of this found in amateur radio practices. Well, what do you say we do a big review and finish out this portion of the audio course? And the review will first start off with rules and regulations. And I'll take a couple of questions out of each area of rules and regulations. Remember, out of rules and regs, how many questions? That's right, 7 questions out of 7 groups. And then we'll go to the operating procedures group, of which there are 5 groups, which means there would be 5 questions. Then we'll take a look at radio wave propagation, of which there are 3 groups inside radio wave propagation. There would be how many questions? That's right, 3 for 3. And then again, we'll review amateur radio practices with 5 groups of questions, of which there'll be on your exam a total of 5 questions. So take a quick break and then let's go for a review to finish out this portion of the audio course. And here we go with Commission's rules and regulations. Beat me to the answer when I give you the question. Let's start at the bottom of the band, 80 meters. Remember where your exclusive CW privileges are? 3,500 to 3,525. That's right. How about on the 40-meter band? Exclusive CW privileges, 7,000 to 7,025 kilohertz. 20-meter band, 14 to 14.025 megahertz for CW only. And on the 15-meter band, 21 to 21.025 megahertz. And be sure and remember that 80, 75, 40, 20, and 15 meters has at least one segment authorized only to extra class operators. And remember the voice portions that are exclusive to extra class, 3750 to 3775. Remember that one? How about 14150 to 14175 and 21200 to 21225? And remember that good hams always eliminate or reduce interference from spurious emissions. And down on HF, 5 watts or greater, remember 5 watts, the lesser of 50 milliwatts. And on HF, if it's less than 5 watts, the spurious emission must be 30 dB below. And let's see, 25 watts on the VHF band, they need to be 60 dB below. And 25 watts or less on the VHF band, the lesser of 25 microwatts or 40 dB below the mean power. Whew, boy, a lot of numbers. But maybe you'll get an easy question like this asking about who's going to be subjected to scrutiny if a packet bulletin station forwards a message that inadvertently contains not legal materials. Well, that is the control operator of the originating station, and conditionally the first forwarding station are responsible. And if you are one of the packet stations, discontinue forwarding the communications when you become aware of it. And remember that the bands are allocated internationally primary service or secondary. And let's see, on 30 meters, don't cause interference to anyone else. Aboard a boat, you must be approved by the master of the ship to operate your ham setup. Telemetry. That's the one-way transmission of measurements. Telemetry is measurements. Telecommand may initiate, modify, or terminate functions of a device maybe on that satellite. So know those two. And during telecommand operations, they may send messages that do have special codes intended to make them obscure or secret. That is allowed. Before putting up that big antenna, make sure you don't need a environmental impact piece of paper, because the land you put it on may have environmental importance. And if you're going to be setting up your station near an FCC station, better be more than 1 mile away. And let's see, how high up can you put up your antennas? Structure must be no higher than 200 feet above the ground level. Not the hills around it, but the ground level. And if you're installing an amateur radio station at a site within 5 miles of an airport, double check that you are within compliance of FCC part, remember that part number? Part, that's right, 17. All right, let's see. Which of the following stations may not be operated under automatic control? Well, we know repeater can, auxiliary can, beacon can, but not model aircraft. Nope, can't do that under automatic control. And the control link is the means of control between a control point and a remotely controlled station. Alien reciprocal operation. That's an authorization to the holder of an amateur license issued by another certain foreign country government to operate here in the United States. And a non-U.S. citizen may hold an amateur service license issued by their government with which the U.S. has reciprocal operating agreements. That is okay for reciprocal operation. Now, may a U.S. citizen holding a foreign amateur service license be authorized for alien reciprocal operation in places where the FCC is in charge? The answer is no, absolutely not. And when we are operating in Canada, what must we have? Except for our own license, no special document is required. Now, from what locations may a licensed alien amateur operator be the control operator? Any location where the amateur service is regulated by the FCC. And do you remember that European country agreement, CEPT, for European countries? IARP is with where? That's right, South America. Oh, you're doing great. What's the name of that radio service using amateur stations for civil defense? That is RACES. And anytime you see on an exam a test question dealing with RACES, always look for the keywords civil defense. Remember, what frequencies are normally available for RACES? All frequencies authorized to the amateur service. With which stations may amateur stations participating in RACES communicate? And the answer is all stations participating in RACES and specific other stations authorized by the responsible civil defense official. All right, just remember RACES, civil defense. Amateur satellite service. That's amateur stations on satellites for the purpose of self-training, intercommunication, and technical investigation. What is a telecommand station in the satellite service? Remember telecommand? Initiate, modify, or terminate. Very good. You're doing just great. Which of the following types of comms may space stations transmit? They can do automatic retransmissions, one-way, telemetry. All of these are correct. Any FCC licensed amateur operator is eligible to operate as a space station. In fact, listen to the space station talking to a group of kids down here at the local school.
Space station is oriented with regard to the sun. And when I did a spacewalk, some of the handrails were pretty warm, and I didn't want to hold on to them too long, and some of them were pretty cold.
Isn't that amazing? That is the space station, and that's coming over the 2-meter band, and many times you'll hear communications like that coming over the 2-meter band from the space station. So there's no telling what's going to be heard out there.
Doing spacewalks, and then also if we're on the space shuttle or on the Soyuz, we have to wear helmets. Over.
Wow, pretty neat stuff. And thanks to AMSAT, and thanks to the American Radio Relay League for helping keep the astronauts in touch with the different schools. When must the licensee of a space station give the FCC International Bureau the first written pre-space notification? Well, no less than how many months? That's right, 27 months prior. And the amateur service bands authorized to the space station would be 40, 20, 17, 15, 12, and 10 meters on high frequency HF, VHF 2 meters, UHF 70 centimeters, 23 centimeters, and 13 centimeters. Now, what is the term for space-to-Earth transmissions used to communicate the results of measurements? That is called telemetry. Right. Now remember the VE questions. Which operator may prepare an element 4 exam? That would be an extra class VE or a qualified supplier. Who must select the VEC questions for element 2? Well, for selecting from the VEC question pool element 2, that could be a tech, general, advanced, or amateur extra class operator. Element 4, that is for your extra class license. Element 3 is general. Element 2 is technician. Element 1 would be the dots and dashes, right? An accredited volunteer examiner, that's an amateur operator who's approved by a VEC to administer or give license examinations. The responsibility of the licensees during an exam is up to the administering VEs, and they're also responsible for the proper conduct and necessary supervision of everyone during an exam session. And what do we call that piece of paper that they get when they pass the test? A CSCE, good for 365 days. And remember that 365-day certificate for a technician to operate on the worldwide HF bands with CW is indefinitely valid, but 365 days only for that tech to upgrade to the general written exam. All right, let's see, we talked a little bit about line A. That's a line roughly parallel to and south of the U.S.-Canadian border. Radio quiet zone, that's the area in Maryland, West Virginia, and Virginia surrounding the National Radio Astronomy Observatory. Anybody know the term for bandwidth expansion? Yep, that's right, spread spectrum. Satellite pass, ascending, going from south to north, going up, ascending. Descending is going from north to south. Remember, on the satellite bands, mode H, 21 to 30 megs, mode V, 144 to 148, mode U, 435 to 438, and mode L, 1.260 to 1.270 gigahertz. And what's that device that receives and retransmits signals of any mode in a certain passband? That's called a linear transponder. And whose effect is it where, as a satellite is heading toward us, the CW sound is going up, and as it goes away from us, it is going down in pitch? That is Doppler shift. How may the location of a satellite at any given time be predicted? By means of the Keplerian elements for the specific satellite. And be sure and join AMSAT. They'll get you all tuned into that. Blanking in a video signal. That's turning off the scanning beam while it's traveling from right to left and from bottom to top. And remember, for video, peak envelope voltage for black, 70. For blanking, 75. And do you remember what it is for white? White is 12.5. What special restrictions are imposed on fax transmissions or slow scan television? They are allowed in the phone segments of the worldwide band if their bandwidth is no greater than that of a voice signal of the same modulation type. Let's see, logbooks. You don't have to keep a logbook, but when operating on an international contest, sometimes to win a prize, they want to see your logbook. And remember, some DX stations use split frequency operation during contests. All right, let's see. Let's get you a good question. How about while participating in an HF contest, how should you attempt to contact the station calling CQ and stating that it's listening on another frequency? Well, first, double check that the other frequency that you're going to transmit on is clear, and then you send your full call sign on the listening frequency specified by the DX station. Your TNC says CMD. What does that mean? The TNC is in the command mode, ready to receive instructions from the keyboard. What techniques are normally used by low Earth orbit digital satellites to relay messages? That's called store and forward. Remember APRS? An APRS, automatic position reporting station with a GPS, can automatically transmit information to show the station's position along, let's say, a parade route. And how about the most common data rate for HF packet? 300 baud, real slow. Or MFSK, Millennium Frequency Shift Keying, 316, and simply Phase Shift Keying, PSK 31, just 31 hertz. What type of receiving system is desirable for EME? Well, your receiver better have a very low noise figure. And for EME, look for that at 144 to 144.1, 432 to 432.1. And meteors, you'll find them between 28 and 148 megahertz. And if you're trying some meteor work, we do that in 15-second sequences where one station transmits for 15 and then receives for the following 15. TE, trans-equatorial propagation. Best afternoon or early evening, reaches out to sometimes 5,000 miles. Long path propagation can provide signal enhancement throughout the HF range, 160 meters through 10 meters. Sometimes you may have to aim your antenna in the wrong direction to get a long path signal. Gray line, that is the signal that travels along the terminator between day and night. CW signals on aurora sound really strange, fluttery, and auroral activity is created by the emission of charged particles from the sun during the peak of solar activity. And the very best auroral propagation is usually CW. A 3-element beam, get it up nice and high, because the higher up you go, it takes the main lobe and decreases the main lobe with increasing height. Same thing if you have a big hill that slopes away from your QTH. Propagation of VHF over 500 miles, tropospheric ducting. Local VHF, local polarization for ground wave is normally vertical. Spectrum analyzer, the horizontal axis looks at frequency. Logic probe, remember what a logic probe does? It's smaller and shows a simplified readout of high and low logic states. Frequency standard, WWV is a good one. That's a device used to produce a highly accurate reference frequency. And remember, it's parts per million times megahertz. So you have to go from hertz to megahertz and then multiply how many parts per million error, and that'll give you the hertz readout error. And let's see, the dip meter, that is a device consisting of a variable frequency LC oscillator and an inductor showing the metered feedback current. Everybody should have a good dip meter. And for best accuracy, how tightly should a dip meter be coupled with the LC circuit being checked? Not very tight, as loose as possible. That's the old dip meter. And what is the effect of excessive phase noise in the local oscillator, the LO of a receiver? Well, excessive phase noise allows strong signals on nearby frequencies to interfere with the reception of weak signals. Now, you're transmitting on your handheld, and your buddy next to you transmits on another frequency, and your reception goes away. That's called, anybody know, desensitization. If all of a sudden his voice comes over, that might be capture effect. Anybody know the blocking dynamic range of a receiver? Any receiver? How many dB? 119, and that's a plus 119, no minus sign, just 119 dB. Intermodulation interference, when two repeaters are in close proximity and the signals mix in one or both of their final amplifiers. And how do we get rid of intermod? By installing a terminated circulator or ferrite isolator in the feed line to the transmitter and the duplexer. Receiver sensitivity, bandwidth, and noise figure. And speaking of bandwidth, you always want a nice narrow filter, because a narrow filter will allow the skirts to cause out-of-band or off-frequency signals not to be pulled in. And the IF circuitry of an RTTY receiver, 300 hertz, sideband 2.4 hertz, And FM, a whopping 15 kilohertz IF is usually found. And the most significant problem associated with the reception of HF transceivers in a vehicle is ignition noise. An alternator whine may be minimized by connecting the radio's powered lead directly to the battery by the shortest possible path. All right, you're doing just fine. Take yourself a good break, and we'll meet you here, if you're on cassette, on your third cassette. And if you're just listening to us on one of our mammoth audio courses, we'll see you back here soon. And I want you to get a calculator. Find your kid's calculator. Get that calculator out, because we're going to need it soon. And we'll see you very shortly when we talk about electrical principles. See you later.